Alright guys, welcome back. Today we're going to be focusing on 8.7 surface area of pyramids and cones. Our depth of knowledge is level 4, and what you guys will be tested on is I can find and use surface area of pyramids and cones. So again, we're focusing on surface area, the area of the surface, that's all surface area is, and in this case we're focusing on pyramids and cones. Both have slants, so this is going to be a little bit different than our prisms and cylinders from yesterday. So, first off, the net of a pyramid. We have some important vocabulary here. We have this net of a pyramid down below. Now, as we can see, this has a square base, which is nice. And we also have these 4 triangles all the way around. So, some initial vocab. First, we have lateral area. That's just capital L. That's what lateral area will stand for. Again, the lateral area is the area of the shape without the base. So, lateral area would be the area of these 4 triangles here. Big B is the area of the base. I went ahead and colored that in with green here. Again, area of a square would be length times width. Area of a triangle would be 1/2 length times width. So depending on what our base is, depends on which area formula we use. L will stand for our slant height. Now right now it just looks like it's the height of the actual triangle, which it is. But when I fold this all up, it would actually be a slanted height. It wouldn't be a height from the center. It'd be the height on the side. And you'll see that in just a few. Capital P is our perimeter of the base, so the area around our base, that will be big P. And of course, capital S is for surface area. So, write an equation for the area of the net. Simplify as much as possible. So go ahead and take a minute, try and figure out a good formula to find the area of this net. Now again, 4 triangles, 1 square. All right. So, for the net for lateral area L, again, we have these 4 triangles here. I just drew them side by side. I expanded it out, stretched it out. And of course, we know that the perimeter, P, is the length of all of them put together. Meanwhile, as we saw in that last slide, our slant height is L. And in this case, it's the height of the triangles. So, P, our perimeter, times L, multiplied by 1/2, because they're triangles, will be our lateral area. So surface area is equal to lateral area plus the area of our base. That's our simplified version. And to find our lateral area, we have to take our perimeter times our slant height and then divide by 2, because again, we have triangles, so it's got to be divided by 2 at the end. Plus, of course, the area of our base, and that depends on which shape we're dealing with. If it's a square base, in this case, it'd just be length times width. Anything else, we'd have to determine that. All right. Lateral area and surface area of a regular pyramid. Now, regular is a very unique term within our geometry. Regular just means that all sides of our base are the same. They're all equal. So in this case, it'd be a square base. So the lateral area of a regular pyramid is equal to 1/2 our perimeter times our slant height. And again, we see our slant height's finally folded up here, so we can see that that slant height is on the side. It's not starting from the center and going up, but it's actually from the side here. And of course, we know that height needs to intersect at 90 degrees at its intersection, so that's how we know that this is the height of the triangle. The surface area of a regular pyramid is surface area is equal to 1/2 the perimeter of our base, so this distance around, times our slant height, L. Again, this is just big L, this is just lateral area here, plus the area of our base. And in this case, it's just our side multiplied by our side. And if they're the same, because again it's regular, it'd just be the side squared in this case. Will it always be side squared? No, it just depends on which shape you're dealing with. So example 1. Go ahead and pause the video for a second if you'd need to try this example out on your own if you'd like. I'm going to go ahead and go through it right now. So example 1, find the lateral area and surface area of the square pyramid. Again, we know it's square, so all sides are equal to 5. From there, we can use our equation. L is equal to 1/2 perimeter times our slant height And surface area is equal to lateral area plus the area of our base. In this case, we can clearly see that our slant height is 9. Our perimeter is 5 plus 5 plus 5 plus 5, or 20. And so we'd have lateral area is equal to 1/2 of 20 times 9. Lateral area, well, half of 20 is 10, and 10 times 9 is 90 inches squared. Now again, we're focusing in on inches squared because our units are going to be squared in this case because again, we're dealing with area, not volume anymore, area. Next up, surface area is equal to our lateral area, which is 90, plus the area of our base. Well, our base is a square. The area of a square is just length times width. So 5 times 5. So surface area is equal to 90 plus 25, giving us surface area is equal to 115 inches squared. Don't want to forget that part. Very important. Hopefully that was easy for you guys. Not too much of a challenge, but again, just be wary. We're dealing with slant height, not actual height. Again, actual height goes from the center straight to the top. That's what we were dealing with in volume. We're not dealing with that right now. We're just going to be dealing with our slant height in this case. And again, here it is. A little bit cleaner, a little bit neater for you guys. And again, I can find my lateral area right here. Lateral area is just the first part of our equation. 1/2 big P times L. All right, example number 2. Go ahead and pause this one if you'd like for a second, this video, and try this one out on your own. From here, we notice that we have a right triangle. So this 12 here, this 12 is not our slant height, but it's our actual height, H. Meanwhile, our slant height, L, is what we need to find on the outside. So if I have a right triangle, and I have two known sides, 12 and this other side that we should be able to figure out, then we can find L. Now if I look at this segment of the triangle here goes to the center of our pyramid. Well, if I know the whole side length is 10, then from the center to one side length should be half of 10, or 5 in this case. So we can go ahead and use Pythagorean's theorem, our old friend, a squared plus b squared equals c squared, where c is equal to our slant height, L. So this will give us 12 squared plus 5 squared equals L squared. This is 144 plus 25 equals L squared. L squared is equal to 169, so L should be equal to 13. And we take the square root of both sides, of course. That's how we get this 13 down here. Now, again, we have a square base here. So therefore, all side lengths will be 10. So when we're finding out our lateral area, we have lateral area is equal to 1/2 P times L. We'll go ahead and split that. Lateral area is equal to 1/2 our perimeter. Well, 10 plus 10 plus 10 plus 10 is just 40. So 40 times our new slant height, which is 13. Well, let's see, half of 40 is 20. 20 times 13, well, let's see, 13 times 10 is 130, times 2 would give us 260 meters squared. Now, as for our surface area, we know surface area is equal to L plus the area of our base. And in this case, the area of our base is once again a square. So, surface area is equal to 260. I got that from right up here. Plus 10 times 10, which of course is 100. So our surface area is equal to 260 plus 100. So 360 meters squared. Again, we're no longer in cubed units, we're in squared units. And on your homework with this, again, These units will already be given to you. You don't need to write out the units. All I need for you guys to answer is the numbers. If you don't have the numbers in there, it's going to throw you off. Here it is a little bit cleaned up. Again, lateral area is equal to 1/2 P times L, which is 260. Again, we find that in the first part of our equation. Surface area is just equal to our lateral area plus the area of our base. We see that area of the base right over here, 10 times 10, which will give us 100, transfers over to 360. All right, getting close to the end, guys. Next up, net of cylinders. So this is a net that we did not see before we left it for break. Now over here we see that we have our base, and over on this side we actually have the area of this our lateral area, the area of the top part of our cone. I don't know why this says cylinder, it should be cone here. Cone. So, looking at this is just a section of a circle. Meanwhile, our area of our base is just a whole circle. So, again, we're dealing with slant height in this case, L. We're also dealing with the radius, R. So again, we know that the area of our base would be pi r squared is equal to area. And then we'll have a very unique way of solving for L over here, for our lateral area. So let's go ahead and take a look. So, for lateral area and surface areas of right cones, once again we have some vocab for us. Our radius is R. Slant height is once again L. We're not going to change that. I'm going to keep it as a cursive L so I don't get it confused with 1. Our big B is the area of the base. Of course, we know pi is 3.1415926, so on and so forth, forever and ever. And then we have capital L for lateral area, capital S for surface area. So the lateral area of a right cone, so that's the area of the cone portion here, not of the actual base, just the cone portion. So lateral area is equal to pi times our radius times our slant height, or pi RL. The surface area of a right cone is surface area is equal to capital L, our lateral area, plus the area of our base. Or you can think of it as surface area is equal to pi RL plus pi r squared. Pi RL kind of sounds like IRL, but keep that in mind if it kind of helps you out. If it doesn't, work on memorizing this. This will help you out down the road. Example 2. A company packages popcorn in paper containers in the shape of a right cone. Each container also has a plastic circular lid. So here's our lid here, and then here's our cone for the popcorn. Find the amount of paper needed to make each container. Then find the total amount of paper and plastic needed for the container. Round to the nearest tenth. So again, we're going to be rounding to the nearest tenth. That's important to know. They're asking us to do 2 things. Find the amount of paper needed to make each container, so we need to find out how much we need for the container itself, and that's just the lateral area here. And then we'll also need to find out the total amount of paper and plastic, so the entire thing. We'll also need to know the surface area. So again, we're just trying to find 2 things here. Now our equation, lateral area is equal to pi RL, and surface area is equal to pi RL plus pi r squared. So, go ahead and take a second, try and figure this one out on your own if you can. All right, so our lateral area is equal to pi times our radius 6 times our slant height L. Well, I don't know what L is quite yet. So it still is making a right triangle here, so we should be able to use Pythagorean's theorem. A squared plus b squared equals c squared to find out what L is. So we have 8 squared plus 6 squared equals L squared. This will give us 64 plus 36 equals L squared. L squared is equal to 100, so L must be equal to 10. When we take the square root of both sides, that square disappears. So L is equal to 10 down here. So I can plug that in over here, and we get L is equal to 60 pi. Now, I know that we're going to round to the nearest tenth here in a minute. I'm just going to keep it like this for simplification purposes. If you're like, okay, I want to find out this answer already, go ahead and multiply those out. We'll be going through that in just a sec. Over for our surface area, we have surface area is equal to pi RL, which we know is now 60 pi, plus pi times our radius being 6 from the center of a cone, or from the center of a circle, to the edge of a circle, that's our radius, and in this case it's 6, so times 6 squared. And that'll give us surface area is equal to 60 pi, and 6 squared is 36, so plus 36 pi, giving us surface area is equal to 96 pi, and I completely forgot my units, centimeters squared and centimeters squared. Now from here I'm going to go ahead and multiply those out, clean it up a little bit for you guys, and we see that we need 301.6 centimeters squared for the surface area of this entire cone. For just the plastic, let me go ahead and multiply that out. Or sorry, for just the paper, we have 60 times pi, which will give us, so 60 pi is equal to 188.4 centimeters squared. So this number right here is for just the paper. Meanwhile, this number down here is for the paper and the plastic. All right, so I included your homework tonight. It's already up on Schoology for you guys. It's 8.7 online homework. Go ahead and try that out tonight. It is due tomorrow. If you guys have any questions, please let me know. I hope these videos are helpful for you. And of course, if you need anything, please don't hesitate to contact me at all. If you're having trouble with any of the homework questions, make sure that you flag them. And be very careful to read the directions, because they will tell you to round it. They will tell you to keep it in terms of pi, which means that you don't multiply by pi. Just keep all that in mind as you're working through this. If you guys need anything else, just let me know. I'm happy to help you guys. I hope you're all doing well. Contact me soon if you need anything. Other than that, take care.